Hello, welcome to this afternoon stream. We're going to be fixing up the blue noise generator, maybe converting it to WebGL, I don't know. I looked back over the code and I think I can do it in WebGL, so I might convert it back from JavaScript to WebGL. So that's kind of stupid of me to have done it in JavaScript and then convert it, but you know what? It's good for testing. We're actually going to start off by testing out the noise. So let's do that. So basically what we're going to do is, I forget what my keybinds are. Okay, I got them. So our noise here, we're going to generate a texture. So we're going to make it bigger. Cool, explain what's blue noise. It's high frequency noise. So white noise is uniform across all frequencies. It has low and high frequencies. Blue noise has high frequencies only. So there's this thing called a low pass that if you've done like any audio stuff before, you probably know what a low pass is. It removes the higher frequencies, and basically if you use blue noise in some sort of noisy thing like my marble path traced game, if you use only the high frequency noises, then you can apply a low pass, and basically remove the noise. So it's basically a uniform. It's really good for a lot of things. It's hard to explain. But I just remembered, I actually forgot about this. Yeah, you know what? Maybe I can introduce. I actually, at the beginning of last stream, I showed what blue noise was good at. But I just remember there's one thing I need to fix, and that's, you see the edges here? I need to make it tiling. So the way to do that is to make it sample relative to, so that way it like wraps around the distance. It's yeah, so I gotta do that. But one of the things I gotta think about first, and actually that I want to test, because maybe I'll just end up converting this all to WebGL. Hold on, I gotta blow my nose. Alright, so before I convert it to WebGL or whatever, the one test I want to do, if it's in WebGL, the wrapping will be Automagic. Yes, exactly. So that's one of the things. If I do it in WebGL, it will just automatically do wrapping for me. What I don't know is, though, save this on my desktop. What I don't know is, right now I'm using jittered grid points, and I actually think it's not generating blue noise because of that. We open up the generation here. I commented out this part that's supposed to generate uniform samples, but when I tested it, it didn't actually seem to generate uniform samples. So I don't know. Maybe if I fix this up. Oh, I think this is wrong, and that's what the issue is. Jitter poison disk. Yeah, so I was using a jitter, and I think it's not generating. You know what? Before I even do this, I should set up the test. But yeah, it's basically supposed to generate a poison disc dot pattern, Poisson disc. That's what this first part's supposed to do, but I think it's pretty slow. That's why I was kind of going, like the original article that is, I should bring this up. The original article here talked about it. In his optimization right here, instead of using the initial binary pattern generation, he used Mitchell's best candidate. And yeah, so that's like the Poisson disc generation. But anyways, let's test this. So I'm doing my testing in shader view, my shader app right here. So there's two kinds of tests we want to do. We want to do a histogram, which I'm already confident of, so I'm not actually going to do a histogram, because the way this works is it ranks all of the pixels and it outputs their rank, and because the rank is 0 to the number of pixels, it's basically, there's only one rank per pixel, so it's basically guaranteed to have an even histogram with this generation method, which is pretty cool. But the threshold test, a bunch of people do a Fourier transform on it. I like to just test the threshold. So let me set up uniform sampler 2D texture. This is going to be our texture that we input. So we'll have the value, texture, DI, too used to shader toy, texture, UV times 0.5 plus 0.5. Yeah, so there's what my bot just posted. There's the link to the article that I based this on. All right, so this will just output testing GLSL error. Oh, this is supposed to be .x. All right, so now I need to load in, copy this bn1.png. So leave it's options, texture, options 0, texture. Is it uppercase texture or lowercase? Lowercase. bn1.png. Here we go. So it loaded in the blue noise texture. I actually want to do nearest sampling for this. Hey, Destructor. I don't think I added options for nearest sampling in this. Oops. Yeah, so I actually have to do manual nearest sampling for this. So that's cool. 4 divided by 64 plus 0.5. Actually, I can just do texel fetch. And I should also make it aspect correct, shouldn't I? So right now I'm setting up a shader for doing threshold tests for the noise that we generated. Because actually, first of all, this looks like it's changing the colors when it's importing. Oh, I wonder if the gamma correct isn't right. Anyways, IVEC2 UV times texture size divided by texture, or actually just times texture size. Oops, wrong one. Oh no, that looks right. That looks the same. You can see though it's stretched out. Actually, instead of just fixing, I can just make it aspect correct like that. There we go. Okay. So here's the blue noise texture. The threshold test is basically where you go max x minus some threshold like 0.9, then multiply it by a high number so it shows out white. And proper blue noise should show a Poisson disk pattern for each threshold. So this actually looks pretty good. They're mostly uniformly spaced. There's literally no points together, but it actually looks kind of like our initial grid pattern, which is really bad. That's what I was scared of. I think if you turn it up higher, it is not uniformly spaced. So that's the issue. It's pretty good uniformly spaced. We generate blue noise texture to be used in the ray tracing algorithm. Yes, I'm going to use it for the marbles ray tracing. This is pretty good though. It's pretty evenly spaced, but there's some big gaps here that are bad, and I think we can make it better. So I'm going to go and try and use the official, I'm going to fix up this official first step generation. So I think my issue was that I wasn't checking if it's 0 here, and I wasn't checking if it's 1 here. Will it generate a noise texture once or use the noise function right in here? No. There's like, that's the thing with blue noise, is there's no just function for the, like the function for the blue noise generation is this like 3-step void and cluster method that is more like an algorithm than a function. It's like, yeah. So it has to be pre-computed, yes. So right here, it's the new generation of it. So what I'm going to do to debug it is I'm just going to post that. I'm going to multiply it by 255 so it renders correctly. It's a scary algorithm. It is like complicated. I haven't really had any things like this for a while where I go to implement an algorithm and it takes me like 3 days to wrap my head around it and all the steps that I'm going to have to do. Anyways, I'm just going to post the binary pattern after this part here in return so that it shows me what pattern it generated. All right, that looks like a pretty evenly spaced generation, but it has that exact same problem as before, where it has all these points around the edges. And I think that's because of my grid generation right here. Pretty confident it's because of my grid generation. Okay, so let's go through and actually generate the texture with this. And we'll see if it looks better or worse. I actually think it looks worse. Easy solution is generate n+2. Yeah, because you actually want it to be tiling. Like the actual solution is to have it wrap around and tile. It'll still have issues because if you see here, it's not just that like the edges there. It's that like the whole pattern changes towards the middle from the edges because it's not wrapping the distance. When you wrap the distance, it actually changes the whole pattern in here too. Well, it's looking pretty much the same. Yeah, it's looking the same. I wonder if it's because I'm not randomly placing my points. I wonder. Hmm. Oh, it's hard to tell though. That looks pretty decent. I feel like making it wrap would probably be better. I don't know. You know what? Let's first of all, we'll try not using the random grid or the jittered grid. We'll try just randomly initializing. Let's make it wrap. That's going to be the next thing. So that's in these compute energy functions here. And right here, I have to use toroidal distance. All right, so this is a lot simpler. All it is a chance of the pixel being active, but only like a 5% chance. So that way, there's no way that there's going to be more than half the pixels active. Damn. Damn. It didn't work. That's interesting. I should add those messages. And I should have kept this part for outputting it here so I can see what's wrong with it. Oh, that looks really good. Oh, so the issue is now that there's no count of points. Okay. All right. That actually looks a lot better though. You know what? You can just zoom the browser window. It's not the same. I tried. It doesn't do nearest interpolation either. Like it blurs the pixels when I zoom in. So that looks really evenly spaced and it doesn't have those same ugly grid patterns that are normally along there. So I know what the issue is though. I know why it failed. When I programmed this, I actually programmed it for the grid with a set number of points. So basically what that did is I expect that it's going to be a grid of 3 by points every 3 by 3. So what I have to do here actually is count the points, I believe. So this n points, instead of having it be a constant, I count it. Try CSS on the image. Oh yeah, good point. I'm not going to bother though. It's just I have to basically download it most of the time anyways. Points equals t size divided by 2. All right, so count the points. Actually, wait, I can do this without an if statement. I feel like that is going to be better. Let's see. So the fixed grid was because the weird was the cause of the weird edge. Yeah. Or no, the weird edge is still there. It's just less weird now. The grid was the cause of the repeating patterns in it. All right, this looks really good so far. Actually, wait, no it doesn't. This is the exact same one as before. I'm an idiot. Of course it looks exactly the same. All right, that looks decent. Let's turn up the threshold. Must be weird, but still not wrapping yet. Oh, this looks like it's winning for the uniform points. Oh yeah. It's actually really difficult. They're both very similar. Is there a uniformity score somewhere? Or are you just comparing by eye? I'm just comparing by eye. Basically, I'm looking at the largest gaps, like right here. So there's like 1 large gap, 2 large gap, 3 large gap, 4, maybe like 5 or 6. And then on the third one, there's 1 large gap, 2 large gap, much less large gaps. So yeah, I think that proper generation works best. Maybe I should try the Poisson disk generation though. Both use the same amount of points, yeah. So if you counted these, they should all have the same amount of points in both images. I think I'm going to implement this in WebGL. Because the other really convincing thing is watch what happens if I try to generate a 256. It takes so long. And right now, using web workers, if I post this open source, everyone's just going to be like, why aren't you using multiple threads of the web workers? So my excuse can be if I do it on WebGL, I don't actually need to do multiple threads. WebGL will do it for me. Another thing I want to have is for generating multiple seeds. It scales poorly anyways. Yeah, but it'll run way faster on a GPU. I'm going to change this to seeds, so people will actually be able to do like 0, 1, 2, 3, 4, 5, and they'll be able to generate multiple textures in one go, so they can just start it and just leave their computer running. Oh man, before I do this though, I kind of want to test using my own Poisson disk generation. I wonder if you could chunk it somehow and still tile it well. Yeah, no. There's no, the problem is there's no chunking the operations because you have to do this step by step, pixel by pixel, but the part that WebGL can optimize is that each time it's doing this add energy call and each time it's doing, so each time it does this huge search through the whole array, the GPU can do this huge for loop really well. Then this add energy is basically like an add operation to every single thing. So WebGL would be really good at this, at adding the exponential values. But yeah, you know what? I'm going to test it with the Poisson disk generation because I don't know, that would be cool. Basically a great algorithm for SIMD. Yeah, like I said, it would be way better if you didn't have to do it step by step, pixel by pixel, but you know, sometimes you can't control the algorithm. The algorithm controls you. Alright, so at the end of this to test, I'm just gonna output it. Alright, so this converting this Poisson disk generation, probably want to do like 1,000 steps. I think this is where you really wish you had compute shaders in GL2. No, actually, I can completely go without compute shaders. Like, you know what? I'm going to be completely real here. The random memory access in compute shaders just make a whole bunch of programmers think, oh man, I can just program this in compute now and it'll be great. They don't realize how goddamn slow and non-cache friendly the random accesses in compute are. Like in OpenGL, when it limits you to writing to specific outputs at a specific time, it's basically forcing you to write cache friendly programs. And like, I fully accept that when I'm writing OpenGL shaders, and I think it's awesome. Anyways, this is a Monte Carlo method. So I think this looks a lot more uniformly placed than the other ones. But you can use compute shaders correctly. I know, but if you're using them correctly, then you can just do it without compute shaders. You can just do it with normal shaders. Yeah, so this basically search nearby points, remove point if within Poisson radius, add point if outside, and then repeat till it's good. Oh, and how does JavaScript do modulo? So I needed to program a proper modulo function so that basically when it went negative, it flipped around to the other side. Yeah, so this doesn't do a proper mod. Oops. So I think it's, yeah, right here, proper mod, pmod. Instead, it wraps around. Let me just look at this code. Pmod value modulo. So if the value is smaller than 0, that returns the modulo -1 minus the value. Otherwise, it just returns the normal mod. So it handles wrapping correctly with negative values. So then when I search nearby y and x here, oh yeah, I actually need to initialize this with a random grid just like I did here. So let me check, how did I initialize this? Oh, I just initialize them with random values. Ah, okay. 4 4s. Yes. Actually, there's 5. So I can just initialize this all with 1. Or actually random ones on and off. So what is this like? Ah, current point at position. The 2 are constant size, 3 even. That's true. That is true. Hold on, I just gotta check something. Alright. And I think I moved my computer too, so gotta reset this. Oh yeah, and I still have this running even though I'm not using it. Alright, so now that this is initialized, for this we now need to count the pixel index. At this point, I need to check if there's a point. Wait. Let me test this generate initial blue noise pattern again, because I think this does generate a Poisson disk. I think I just need to either make it larger spaced or oh no, I forgot to initialize it. Oh, I must have made a mistake or something. Oh, I'm not even initializing it. Like, didn't even allocate it. That idiot. Stupid me. Alright, so also, if I want to initialize 1/10 of points with this, I can actually still guarantee a certain number of points are initialized. I don't need to count the points. I don't need to count the points. So var number of points, we can set however many points we want. So the total, so total size divided by 10 would be 1/10 set as points. So then what we do for this is we I want to resize my sprite on this thing, but I'm making it in Unity. It's going to stretch and look like total garbage. It always looks like garbage if you stretch it. You just have to make it a higher resolution. So here I basically just create, I'm going to do a random ordering. I'm going to pick random numbers out of a hat. So I'm going to create an array with the total size. I mean, it's like 64 by 64. If it gets stretched to 100 by 128, it's going to look bad. Yeah, there's nothing you can do then. You just got to change other scaling methods like nearest neighbor or linear. So initialize the number of points we want in the hat with 1. And then initialize the rest of the points in the hat with 0. And then when we're initializing our values here, we generate a random index from the hat. We sample that index, and then we splice that from the hat. So basically we pick values out of a hat. So we add our number of points into the hat, and then we pick them out. You usually have your assets 2 times the max size they will ever be seen or have some compromises. Yeah. So that's why people always do it bigger, because you basically, you can always make it smaller later, but you can never make it bigger. So this looks pretty good. I want to see how the number of points changes it. What if I do 1 out of 100 number of points? Oh, yeah, so it is generating a Poisson disk pattern. Look at that. Except it's not wrapping. So the pattern generation here doesn't wrap. Oh. Ooh. Okay, so I am going to do this. I am going to do this in WebGL, and I'm going to make it wrapping, because my Poisson disk generation here is wrapping. So let me try and get the same pixel density here as in that. Is that about the same? It's kind of hard to tell. These points aren't per pixel. So that's one of the things. Yeah, so these have really good even spacing. They seem pretty much equal, honestly. So that's really good, because that means that I can just start with my Poisson disk generation right here. Alright, let's convert this to WebGL. Let's do this. So we aren't going to need this worker anymore. We're going to be doing it all in where? Where's our code? Right here. It's all going to be in the JavaScript and GLSL. So now we're gonna I love how I spent all morning programming this and now I'm just gonna rewrite it. That's fucking classic. Alright, I'm gonna put some music on. I'm gonna go and get something to drink. And then we will start doing this in WebGL. Alright, I'll be right back. If you're doing 2D in Unity, in the sprite options, there is a border. You can choose how the border wraps or tiles. Okay, let's get started. So I'll need any of this. If I right click and do UI, there's no border there. Oh, I don't know for the UI then. What's NGUI? Oh, Next Gen UI Kit? Okay. So what I'm going to do is just in case I want to go back to this, I'm going to copy this as index copy. So then I'm going to erase this and start it from scratch, or mostly scratch. Really delete all of the web worker stuff. Unity's old GUI system. Oh. Or UGUI was it? I don't know. Did you have to do like GUI.button and GUI.textbox, or is that the new system? Yeah, that's the old one. I liked that one too. It worked. It was really easy to use. Alright, so I'm gonna need my GL context. I'm gonna get the canvas element, set its size. Now this is going to require WebGL2 context, I believe. WebGL2. Panel work, good stuff. I wish. Oh shit, BRB. Hope everything's good, Simplevar. I wish USS was working for the game. You mean CSS, right? Yeah. Style all my UI in a style sheet. It is really nice that way. Change colors. I gotta go through all my prefabs. Yeah, you know, that's the nice thing about having materials. You can actually, you should be able to do this with prefabs too. Select multiple prefabs and edit the colors all at once. I'm watching the guy and the way he's solving it. So they add CSS for games. He made some static thing that works in editor. Huh. Yeah, you can always do that. You can always make editor extensions in Unity. Alright, well, Now that we've got our GL context, basically just got to create an update loop. I will admit it sounds like nice. I don't like static that much though. Yeah. What do you mean by static in that sense? Oh, it's like static across everything, like global. There's no select prefabs or anything. Yeah, like global variables, yeah. Oh, so I guess right here, I should actually initialize all the textures I'll need. Okay, so I'll need a fixed point texture for the actual binary values and the output values. I'll need a float 32 texture for the energy. I'll need a float 32 texture for the ranks. Yep. I think that's it. I just don't practice proper concerns in dealing with globals. Alright, I think I'm just going to be copying a bunch of stuff from right here. I have my new frame buffer and new texture functions and new shader functions. I'm going to take those. For compiling shaders, and then where's the new texture function? Right here. It is part of the game, isn't it? I'm modifying my UI colors through it. It doesn't get shipped with your game. When you build your game, it doesn't include any of the editor scripts. Yeah, you don't even need that. Just try accessing any of the editor scripts in your normal scripts and then building your game, and it'll give you errors saying that it can't access those because when it tries to build it, it doesn't include those, so it can't access them. that's like a huge annoying thing too, because if, for example, you have like an A# pathfinding script that you use in your game, you can't have that in the editor. You need to have two separate A# classes, one for the editor and one for the game. Like they're actually separate pieces of code. Can't the editor reference the game's logic? Yeah, I think so. But the game can't access the editor's logic. Yeah, like the game can share code with the editor. Yeah, just only the one way. Alright, still gotta copy these. You got to scale better, good stuff. So actually all of this is just going to be generating a new frame buffer, not even any texture. Okay, let me think about this too. If I need to feed one into the other, yeah, so I don't think I need two of each element. Then FBO, energy text, energy FBO, rank text, rank FBO. Oh, so I'm also gonna need a where is it? Right. I don't know if it's right here where I set the type. Wait, let me see. Format. So yeah, I want this to be red, green, blue A32F. I believe. Or maybe red 32F. Color renderable. I can't render to that. I can. Wait, what does color renderable mean? libgl2 float texture. It's inferred by GL Red Green Blue A and GL Float. Okay. Alright. I'm just going to use GL Float then. Alright, so width by width. Nearest filtering is good too. I don't care about clamp to edge because I'm going to be using Texel Fetch. Yeah, no one talks on voice in our Discord, at least yet. Yeah, but I go to Discord, then I'm bombarded with all those servers. You can choose what servers you're on. Feel bad to just leave them. I actually have 2 Discord accounts for different things, which helps me not get bombarded by stuff like that, or at least not when I don't want to. You can mute servers so that you stay in them and they don't bother you. Oh, I didn't actually realize you could mute servers. Alright, so these are our textures we need. I guess the first step is the Poisson disk. Gonna copy it from here. So I'm gonna include the, I'm just gonna put the GLSL shaders right here. Okay, so this shader is going to be version 330. I should actually just add this to the shader when I'm compiling it, if I don't already do that. What kind of videos does Brackley's make? Is it game development? Unity specific videos. Ah, okay. Wait, how do I do this here? Oh, I include the version right here. Teenage, since I see something actually cool by him. I found out about Ludum Dare. Oh man, Ludum Dare is so popular. Do you know what there's actually a really interesting way of doing compute like writing in in like OpenGL, normal OpenGL. You actually do a triangle for each pixel, and then in the vertex shader you basically do the pixel processes in the triangle, and then you shift the triangle to the place you want to write or output. But of course, it's a lot less efficient because you lose all of the tiling optimization of the GPU doing it in batches. I'm like, why is there itching in my ear? And there's like a cat hair in my headphone. That explains a lot. Ludum Dare is sick though. When's the next Ludum Dare? $76 days. Oof. Oof, that's a while. Oh man. I can never enter something like Ludum Dare. Why not? Game jams are my favorite thing ever, actually. I have not yet dared to loot him. It's a good point. Because I have a full-time job and that would interfere. That's a good reason. I don't know about you, but when I do game jams, I stay up all night for like 48 hours straight. That's like the fun. Done a game jam, so I can't tell you what I do. Go to itch.io/jams and do one of the 1 hour ones. There's 1 hour game jams that run every week. The whole point is to just do something that's like not serious. One hour, well, that's how long it takes me to create a name. You're not supposed to create a name first. You're supposed to make your game and then assign it a name afterwards. Alright, so that's the vertex shader. PD. I thought you referred to naming variable. Well, for the game I'm currently working on, the name was really easy. Really? This is just going to be at the top of every shader, so I'm just going to add it. When I load the shader here, sometimes names take years and then the whole technology becomes obsolete. Fucking harsh, man. Alright, so right here at source, I'm going to do version 330/n precision high p float. So now I don't need to write that every single time. More, give me more. Give me more flops. Man, this Mirror's Edge soundtrack is amazing. Oh my god. And it's 5 hours long. Amazing. Oh, okay, so I am. So for the poison disc generation, at least, I'm going to need two textures because I'm going to need to feed in one to the other. Uniform int step. Poison disc. Exactly, it is poison. Set this up. I'm just going to output green. I'm going to compile the shaders. So this is one of the main reasons too I use gedit, is that if I'm editing like an HTML file that has JavaScript, GLSL, CSS, and HTML in it, in gedit, I can go and change the language to OpenGL or JavaScript or whatever I'm actually working on, so it always highlights it correctly. Alright, so full screen vert, compile, vertex fragment shader, get element. Can I link? I'm sorry, man, I don't let anyone post links. You can share them in the Discord. And then, like, if you post it in the Discord, you can basically go off on a whole tangent talking about whatever it is, and it just like talk all you want in the Discord. Like, that's the thing, is you can literally post paragraphs in the Discord. You can't do that in Twitch chat. It's links. The command is links. Or just L. Yeah, there's also the help command for the bot that lists all the commands. So PD inner HTML true. And then we need to compile this to a program. Then I need to get the uniforms. Maybe I should create a wrapper for the shaders. Function shader, shader, point shader, uniforms. And I think it's gl dot get uniform location. I think that's all. Let me make sure. Get uniform location. Oh yeah, I also need to feed in the shader program. Stop program. Okay, there we go. And I don't even think I need to store the uniform names. Actually, thinking about this, I probably want to store it by the uniform names. And this is the amazing thing about JavaScript, is I can go for uniforms.length. Instead of assigning the array index, I can do this dot this uniforms I. So this way it loads the shader with the uniform. Hell yeah. This is a really nice method. So this way I can just go poison equals new shader, pass in the vertex and the fragment shader, and then pass in an array of uniforms, the texture, the frame, and it'll automatically load them, which is awesome. So then we're going to do our render loop here. Actually, what we're also going to do, where is it? Yeah, when I initialize, I set up a whole bunch of functions, or I initialize a whole bunch of WebGL values just so that it's initialized. I don't need some of these though. Sorry, I failed to actually post the image properly. Alright, wait. Am I logged into Discord? Yes, I am. Look, but you can't touch. I don't know what I expected. I did forget. Yeah, okay. For a second, I almost forgot. I forgot to switch the Discord scenes. Right. I'm also gonna need a full screen triangle right here. Full screen quad. Alright, I don't think I need most of these because I'm not going to be downloading or uploading textures. I don't need these. I do probably need these blending polygon offset fill options though. I don't need the depth function. I don't need the clear functions because I'm not going to be using clear. So yeah, I think that's good. So now use program, shader.program. Actually, I should maybe assign values here. So that I don't need to set these. I don't know. Whatever. Uniform. I don't even need uniforms right now. Oh, I do need to set up the viewport though. What do I do here? I set the viewport. Yeah, so I just bind the frame buffer and set the viewport. Okay. Changing all this stuff again after I wrote it for the web workers. Now we're converting it back to WebGL. Oh wait, I also need to bind the array buffer and then unbind it. Actually, I think I should just be able to bind it once right before I do everything and then just keep using it. So I think maybe just right here after I initialize it. It's already bound. So then gl.draw arrays 0 or gl.triangle strip. Triangle fan, which one is it? Triangle fan 0, 4. Alright, so this should draw green when I click generate. Error. Invalid version directive. Invalid version directive. Alright, let's look. WebGL to GLSL version 3. Oh, I have to do version 300 ES. Random stuff. 2.7. Sometimes find myself headbanging to classical music. I love classical music. Varying illegal use of... Oh no! WebGL2 also has different variable names. It calls these input values and it calls these output values. GL frag color, undeclared identifier, L value required, can't modify a constant, dimension mismatch. Oh, this is supposed to be in, this is supposed to be out. Text image 2D, current program is not linked. Error, text image 2D, valid internal format, program isn't linked. Oh no, what am I doing? What am I doing? Program isn't linked. New shader, VS. New shader, program, compile, PS. Invalid internal format / type. Oh no. Is it not supporting the why it I mean it I know it supports floating point textures. Why isn't it letting me create a floating point texture? Following values are additionally available. Format. Take the data type of Texel. I'm using OES float extension, using WebGL context. Combinations are listed in this table. What table? This is a giant fucking document. Oh no, Simplivar, that's the worst. It is rage-worthy. I think here it's supposed to be red, green, blue A32F. Yeah, so that worked, but the current program is not linked. But it is linked right here. What is happening? Oh, passing in the wrong value. Boom, there we go. Okay, we got WebGL set up. Alright. So now we can generate the Poisson disks. Alright, instead of done, state equals -1, state does not equal -1. Alright, so this will keep track of the state as it goes through. The state is equal to 0. Alright, so let's actually do this Poisson disk shader now. So the first thing we're going to do is we're going to check if the frame is equal to 0. Then it's just going to initialize. Going to use this hash function to initialize. At least I think. Unless I want to upload random texture data. Nah, I'm going to use this. The other thing is I'm going to pass in the seed. Like that. So then when it initializes here, this frag color equals UV. So I should actually do two things here. So what uniforms? I'm going to have a float uniform and an integer uniform. For integer data, x equals frame number. So we'll seed z equals width, w equals, so we'll seed y equals size / width, resolution. Alright, now I need to initialize those values. I'm going to create buffers for those. So I'm actually going to use this integer data to keep track of the frame. Set frame to 0. Set the seed. Set the size. So now when it runs the Poisson disk program, also going to initialize some uniforms. And then I'll load the texture data after once I actually need it. First I'm just going to initialize. Alright, so that should initialize it with noise. What I actually want here is an absolute UV. So what I think I'm going to do is I'm going to do uniform F data here. Do UV times a resolution. So F data dot Y. So now I can just do IVEC2 UV 0 XXX. It'll output the same values. Alright, so now I gotta make sure this works, and I need to swap the buffers. So first of all, I need to set these values. So iData set to iData, uniform 4FB, FData set to FData, and then our texture. Alright, so this is the part that's like, it's like different. I need to bind the texture. I believe I don't know what texture. I got the hiccups all of a sudden. I don't know what's happening. Okay. So to pass in the texture as a uniform, I'm pretty sure I bind it, and then I pass in the active texture. Like that. Alright, so this should output noise. Error, frame undeclared identifier, wrong types, no, it's left hand type float and right hand type int. Oh, this is supposed to be idata.x. There we go. Okay, so it output noise. That's good. That's step 1 of the Poisson disk. So that's good. That means we can continue on with the rest. So I'm just gonna copy this code. Alright, now we gotta convert this and make sure it's good. So instead of UV we have U we have UV. To make sure this doesn't go above 1, I have to do minus an epsilon, just to be safe. Alright, find nearest thing, texel fetch, buffer. Pmod, instead of I resolution, this is actually size / resolution right here. Instead of Ri, just copying these as constants. And then instead of iframe right here, I've got my idata.x where the frame's stored. Alright, let's see if this compiles. I don't think it will. Yeah, it has an error. That's a lot of errors. P undeclared identifier. Where do I declare P? Right here. Oh, right here. I don't know what happened that time. And you know what I just realized? It's actually not uninitializing the variables after it's done generating. That's something I'm going to have to program in. 0 undeclared identifier. One thing I just want to look at, because this GLSL shader is turning out pretty big. GLSL minifier. See how this works. Hey, it works. Maybe I'll have to use this then. Alright, I bet I'm using U here instead of UV. U, undeclared identifier, exactly what I thought it was. Awesome, okay. So it got the first pass done and it compiled. That means we can just loop it now and swap between the two frame buffers. And there's also the option of displaying what's being generated so that you can see what it's doing. Which will slow it down a little bit, but be cool, so you can see exactly what it's doing each pass. Yeah, we'll see. We'll see about it. So, first of all, I gotta swap between frame buffers. So output to the binary frame buffer, input from the rank texture, and then swap those two. I'm actually going to create a wrapper for the frame buffer. It'll make it easier. I could just do this all in the FBO function. Awesome. That makes it a lot easier to swap FBOs now as well. So now instead of doing all this too, I can just do just way shorter. Alright, so now rank.texture, binary.fbo, AFK long while. Is your internet doing better now? Anyways, I'll see you when you're back. Maybe. Alright, so now I need to swap these. Temp equals binary, binary equals rank, rank equals temp, so that swaps them. And then I also need to increment the frame like that. Frame buffer not complete has an effective format of red, green, blue A32F, which is not renderable. What? What the heck? You can fix it by calling extensions get floating point texture frame buffer. WebGL is fucking stupid, man. Oh my god. This extension for WebGL2 use the extension color buffer float. Alright, so get extension. If GL extension OES texture float turns extension object or null if the name does not match. Okay, so if not, or floating point textures. What? It actually doesn't support it? What the heck? Did I spell that wrong, or like what? Texture float. This is ridiculous because I'm rendering to textured floats. In that, when I was doing that threshold test before, I'm rendering to textured floats. Texturing, this extension enables color buffer stoat, which allows rendering, implicitly enables. For WebGL to use the extension. Oh, okay. It's available by default. Oh man, WebGL 2 is confusing, man. Jesus. Alright, so if or not extension, okay. Alright, apparently it's working. Let me try rendering it. Bind frame buffer. Frame buffer null. Wait, WebGL lit frame buffer. Lit frame buffer. And the draw frame buffer. You know what? Screw it. I don't actually need to test this because technically I already tested it right here. What I do need though is a way to calculate when it's going to be done generating. Because as you can see, it can basically keep going for a long time. I mean, the larger the disk radius you get, the slower it is. So for this, I'm going to have a pretty small disk radius, I think, of like 2. Or maybe, like, I kind of like 5 or 4, because it's actually decently far away. It actually gives it a nice pattern. I think I'm going to do, I don't know, I'll try different ones and see how the noise it generates is. Do 3 to start. Alright, so state 0 will go on for I guess this is like 5 times 60, like 300 frames. Kind of finishes after 3 though. I want it to be perfect though. I'll do like 200 frames. And I gotta make sure it stops, so this swaps every 4 frames between adding and removing a point, and you want to take the final measure the frame right before it adds another point. So to calculate that, like this frame ID 2 is that frame right before. So if you do modulo, basically I have to divide by 4 and add 2. So that's 202. This 200 is already evenly divisible by 4. So if I data bigger or equal to 202, let me just calculate this. So 203 would be 3. Yes, okay. So 202. I'm gonna fix this. At least try and make it better. So once it ends this, you've got the initial binary pattern. Or once you have this, you can build the initial binary pattern. I actually need to create another shader for converting that, and I'm starting to think, is this even going to be that much better than the web worker? I mean, this could technically just crash once you start trying to do a 4K texture, because it's going to try and compute a giant amount unless I do tiled rendering. So tiled rendering would basically be rendering small parts piece by piece so that it doesn't lag too much. And then on the other hand, if I do web workers, I don't need to worry about any of this. I mean, tiled rendering shouldn't be that hard though. I should just be able to move the viewport around. I am not sure. I'm just going to continue on with implementing this. Or I could just do it in a web worker where I know it's never going to crash. Well, I already went this far, so decisions. Poisson disk to binary pattern, fragment shader. So all this does is it takes in this point, and if frag color equals step 0 dot all right. So that just converts the Poisson disk points to an actual binary pattern. So it reads the points from the buffer, it writes out 0, it writes out white, or 1 if the value is... Wait, how does step work again? I always forget what step does. Step function specifies the location of the edge. 0 is returned if the edge is bigger than x. 1 is returned if x is over the edge. Alright, yeah. So this is supposed to be negative. Alright, awesome. So also, we're going to delete our shaders here to begin cleanup, because we don't need them anymore. And for this step right here, actually, I'm just going to compile the shader and use it once, and then decompile it, I think, because I'm only going to use it once. I don't know. Alright, so now here, actually I want p2b.program. Actually, it's basically all the exact same code here. Draw arrays. Awesome. So that converts it to the binary pattern, and we have our initial prototype binary pattern. So now we can advance to the next state, which is calculating the energy clusters. So we need to compute the energy calculate binary cluster energy. And actually, because the way I'm doing this with Texel Fetch, I need to pass in these uniforms. All of the uniforms. Alright, state plus plus. Reset the frame to 0. Okay, so let's program the energy calculation now. This is going to be a decently hard part. Actually, it's not going to be that hard. Basically loop through all of the surrounding pixels. So this is the part where I'm going to have to do toroidal distance as well. I've never done toroidal distance before. So I believe what you do is you compare if the distance is bigger than half on an axis of half the screen size, then the distance is closer going through the other side of the screen and wrapping around like a torus. Alright. So we need to loop through all of the surrounding things. This is part of what makes this so slow. I'm actually going to output the resolution in the iData as well. And then we need our sum, our energy value. So then what we do here is we sample the point, or if the point does not have something there, then skip. Otherwise, add the energy value. Maybe I should do a test for the toroidal distance to make sure it's correct. Nah. It's pretty simple. So I'll convert the current UV to an integer to compare the difference. Or actually floor the UV. So then right here, this is going to be the hard part. Distance equals that minus that. If the distance dot x is bigger than half the screen size. So I'm actually going to output as well half the size so that I don't need to look this up again. So that's bigger than half the screen size. How do I calculate it wrapping around though? Would the equivalent of wrapping be mirroring it and calculating the edge to the distance? Yeah, you know what? I need a test for this because I am not sure. Okay, so I'm going to set up 2 points each on the side of screen, P1, P2. Set up a normalized UV. Output value. Alright, so there's the 2 points. I'm going to set one of the points to the mouse, so it's easy to control. How am I even going to... B plus equals length P1 minus P2. So as you drag them, they get farther apart. After a certain point, like right here, it should start getting lower again. So diff P1 minus P2 if abs diff.x bigger than iRes bigger than 0.5. Diff.x equals what is diff.x equals? Equals minus absolute value diff.x times sine. Yeah, so it starts going down again. Alright, so here it should start getting closer as it wraps around. So now we'll test it. I'm gonna need to close my blinds up soon because the sun is shining right in here. Del y greater than 0.5. Awesome, so that is toroidal distance. Awesome, so actually what I was doing actually works good. So one that dot z minus absolute value dis.x times sine dis.x, and then I do that for the y. Alright, now the energy. Oh, I also am going to need the sigma in here. Energy value plus equals exponent distance squared. So wait, GLSL distance squared. So I guess I can just do dis.x times dis.x plus dis.y times dis.y. Oh, wait, I'm an idiot. That's just dot dis times dis, and then multiplied by the sigma, which is a w. Hell yeah, that's actually pretty fast. I wonder if I can do this without branching. This without branching. Let me try this, wait. So dist equals mix. So you would need to do this for each vector. So step. Okay, so it works with any type. Alright, so I should be able to do distance equals distance times step. Actually do dstep. Generate a stepping function for absolute distance over dat.z. Then here I can just do dist equals dist times 1 point minus step d. Plus this mirrored distance times the step. YY minus times step d. Alright. Should calculate the toroidal distance. Alright. Calculate binary cluster energy from fragment shader. There we go. We got another shader done now. I wonder what the next step would be here. I guess it's the ranking. So first of all, we need a shader that updates the values, the energy values. Add binary cluster energy fragment shader. So instead of looping through each one, all this does is read the current value, like Texel fetch. Okay, what am I? I'm not even outputting the energy value here. So what this does is it reads the current pixel, and then it adds, calculates the distance and adds that. So the X is the seed, the Y is the size / resolution, W is the sigma. I guess I'll feed in the pixel position in the I data. Alright, so current position. I guess I could just do this with an additive pass too, without actually sampling the shader. Now that I think about it, I could just switch to additive blending. Yeah, I'm probably just going to use additive blending, I think. So I just need to remove this loop. Use this part where it calculates the distance. Right there. And then that exponent right here is what we need. Just outputting that. Okay, so that with an additive blending will add energy to each pixel. All right. Give me a second. I'm just going to close the blind. Sun's shining right in now. Okay. So I moved my blind in where the sunlight is, and now I can't read chat. Fucking good one, Ethan. Oh, good one, Ethan. Oh, I'm not feeling good about this WebGL version either. I think it's actually going to be slower for small blue noise textures, so which makes me think that I should include two options. I should include an option for the WebWorker version that'll work better with slower, and offer a version for the WebGL. That's a lot more complicated. So now the next shader we need is a ranking shader. So this is going to be the part that may not be the most efficient thing in WebGL. It's going to render a single pixel that just calculates the smallest value. And this just made me realize too, it's going to actually output to a texture. So right here, it's not going to input through a uniform, it's going to input through the texture. So I should have actually done this first, or in the order that I'm doing it. So this one is ridiculously simple. All it does is search through all of the pixels and find the minimum value. So v texel fetch buffer xy 0.x if v is smaller than min value. Set this to min value as well as the minimum UV, and then output this. Put the minimum UV. And then we need a version of this too that finds the maximum energy. It's literally the same as this, but it just does greater than instead of less than. So now we need to change this so it doesn't take the input from the idata.zw. It takes the input from I'm actually going to need a small 1x1 temporary buffer now that I'm looking at this. So I'm just going to call it temp, texel fetch, temp. Oh wait, there's no input buffer, so it's just buffer. Buffer, just reading the 0 pixel. So that's really easy. Alright, now that adds the binary cluster energy. Oh no. Wait. I just realized I'm also going to need to either count the number of points or initialize it with a set number of points somehow. I'm probably going to need to count the number of points. Yeah, I'm probably going to need to count the number of points. Because then that'll tell me how many times I need to run the algorithm or step the algorithm. Yeah. So let's create the next steps of this now. Back when my internet still wasn't sleeping. That sucks, man. I feel you, though. I hate when you can't control the internet. It's like out of your power. Oh yeah, I'm going to allocate this temporary FBO now. Takes 5 seconds to load the freaking emote. Damn, dude. Well, I'll see you around. Since you're on Discord now, I might see you more, too. You have a good day as well. I'm going to be getting off soon anyways. Alright, calculate energy values. Use program. Poisson. Or actually, wait. I need to compile some new programs now. So what's the first one I need to do? Calc energy. Add energy. Or actually min energy. Max energy. Add energy. That should be good. Just need to initialize these shaders. what did I call this shader? Just energy. So now I'm just going to copy this for a whole bunch. Min energy, max energy, add energy, and that should be good for now. We can also delete the shaders. And this will remind me to clear them afterwards as well. Oh, this is supposed to have PS on the end too. I'm hoping all this WebGL programming will be worth it and it'll be way quicker. I'm thinking it will be quicker, I'm just thinking it's not going to be as quick as I'm hoping. Man, it's boring initializing shaders. But I just gotta get this out of the way to actually run them. Okay. Now we can actually add step 2 to calculate the energy values. So calc energy.program. Set up the uniforms. Actually, since all of these uniforms are used for exactly the same, I can probably just create a prototype use. And I can do this. Stop buffer. All right. So now I got a shortcut for using the shaders. Use rank.texture. Oh yeah, this is going to make it way shorter. Okay, so which texture am I going to be inputting to this? I'm going to be inputting the binary texture. I'm actually going to bind the frame buffer before the shader. Alright, so then draw arrays. So that should calculate the energy now from the binary. Oh wait, forgot the most important part. Setting the frame buffer that I just talked about doing. So we're going to store the energy in the energy frame buffer. Then we're going to add this, increment the state again. Should probably just do this in a switch statement. Alright, step 3. Oh, wait. I actually have to calculate the number of points as well. Huh. This is going to be a whole thing. Step 1. Count number of points. So this is the part where we actually need to convert some data from the GPU to the CPU. We'll just use read pixels because it's going to be called once. But it's going to be after our binary code here. What it's going to do is just count. Alright, so int count equals 0. I wonder if I convert float into bits, then can I convert that back on the JavaScript side? Directly out, JavaScript only has one number type, which is effectively a double. It gets converted to double. In other words, now the pixels are float 32s, it's no longer bits. So I guess my solution is to read these out as integers. I'll try reading pixels as integers. So in the z element of the integer data, I'm actually going to output the total size, width times width. So I can loop through the whole thing like this. Oh, actually, never mind. I still need to loop through it because the samplers use 2D coordinates in this. Stuff that I'm trying to copy over from JavaScript that doesn't. completely apply. Count plus equals int step plus an epsilon pixel fetch buffer xy0. Alright, so this counts up the number of points in the binary pattern. Hopefully outputs them as int bits to float that I can then read with GeoRead pixels. Hopefully read using red green blue integer type, like using int type here, so that I can just read the integer data without having to do some sort of custom float encoding. So this is going to actually be a good point, because it's going to let me count the number of points and actually see if this is working effectively. So now I need to initialize this as a shader called count. So I'm going to load the shader here. And then unload the shader like we did here too. Alright, now we're going to output this to temp. We are going to set the viewport to 1, because that's the size of temp. We're going to use the count program on the binary texture. And then we are going to run that and call GeoRead pixels. So we're going to see if this works. So read pixels one by one. It's integer data. Format. Specifying the format of the pixel data. Green, blue, and alpha components are red. Data type of the pixel data. Alright, I'm going to try both of these. I'll try integer to start. And then alert counted int v0. And it's going to set the state to something where it does nothing. Alright, I expected errors. MV undeclared identifier in the find minimum energy shader. Cannot assign L value. Alright, find minimum energy. Oh yeah. Counted 0. Okay, that's a failure. Read pixels incompatible format or type. Ah, okay. Yeah, so that didn't work. Red, green, blue, A. Alright, there has to be a way to get integers out of these floats. Has to be. Heck, let's try it. Pixels type does not match type. Ah, damn it. Maybe I have to read out the bytes. Oh, I can use an array buffer. Does this work? Buffer for target is null. Huh. JavaScript bytes to int. Okay, without using seated 16 live. Counted 0. Int32 array from uint8. How do you convert a bunch of bytes of a uint8 array into an int32 array? Wait. You can just feed in one array to the other? No way. New int32 array int b. Is it actually this simple? No, it's not that simple. So let's try reading them as floats. Int b is not defined. Oops. Incompatible format or type. Wait, really? Wait, WebGL read pixels from float buffer. Can you not even read floating point values? Or gl.float What in the heck? Is limited to red, green, blue, A. Oh no. Oh, it's limited to unsigned byte types. Oh shit. Oh no. Oh no. Well, that would explain not being able to output that. Let me just try outputting a float. Oh no. If it actually doesn't support 32-bit read pixels, then there's no way for me to do this. You can call... Oh, really? Wait. Pixels from buffer, gl.read buffer attachment. Format type data. Okay, maybe I have to do gl.read buffer. This guy doesn't even assign the floats to floating point textures though, so that would explain why it works. Let's try read buffer. Oh, I'm not assigning frame buffer right here. I am not very smart today. Temp is not assigned. Temp is assigned right here. FBO. Temp is undefined. Is it sure temp is undefined? Because it's right here. WebGL smallest FBO size. Open. Minimum frame buffer size. Is there a minimum frame buffer size? Let me check. If not, this.fbo. No, it's working. It just says temp is undefined. What the hell? Temp equals new FBO right here. Let me remove the closure around here. Try and actually access temp. Temp is not undefined. It's right here. What the heck? What is it doing that it says temp is undefined? Find frame buffer temporary.fbo. What? So what's happening here that temp is defined, but it's saying temp is undefined? How does this work? Like, actually, what's happening here? I'm really confused. I assign temp right here. I initialize it. In the console, temp is initialized. Temp.fbo is initialized. In the code, right here, temp.fbo is null. What the hell? Alright, paused. Temp is undefined. Oh my god, it's... Oh, stupid switch statements not having their own scope. Stupid switch statements, man. If I put this like that, it should put it in its own scope, I think. I hate that they don't have their own scope. Yeah, it's the way it goes though. Temp is undefined still, holy shit. So in C, that would have created its own scope if you did like... Oh, I think this would actually be the time to use let. This is probably when I should use let. It actually worked! Wait, it worked? What the hell? Okay, so now let's try and actually get this data out of the float. So I don't know what the actual value is, so there's actually no way for me to check unless this just looks correct. So once again, I'm just going to try reading an int32 just in case it lets me. No, it doesn't. Pixels doesn't match type. So what if I try and read an integer? Invalid form, incompatible format or type. No, so I need to read float, or I need to read it as a uint8 array. Incompatible format or type. So I guess I need to read it as floats, as far as I'm aware. Okay, so actually, I'm stupid. I forgot. I went through here and I encoded it as a float. So now this is going to store it as an integer, so it should have an incorrect value. So the idea is to read it into the float array where it's incorrect, and then I'm going to convert it to uint8 array where it's the raw byte values, and then I want to know how long this is. 4. So that's incorrect. JavaScript float 32 array to bytes. Float into byte array. Use the buffer. Awesome, that worked. Awesome. Okay, amazing. So that means now that it's in the uint8 array, then I can go to the int32 array that's the actual format that it's on. And now this first value should probably be our count. Counted 11. No, it's wrong. Huh. Maybe this is supposed to be fv.buffer. Oh my god, it's working. Hell yeah. Alright. I'm super happy with that. It's counting the number. So this basically means now that we can, if I go down to my plus and disk shader here, and I increase the radius, or I decrease it to 1.5, it should increase the number of points. Points increase to 912. Alright. So I just need to make sure there's not more than half of the thing is points, so that 1.5 should be pretty good. I'm going to keep it at 3 though, just for testing. But that's awesome. So that's actually a pretty good ending point. We know that we're counting correctly, and we're basically set up to do we have most of the shaders ready for doing the WebGL version. This actually took a lot longer than I thought. I guess I was pretty slow this afternoon. Anyways, we're going to be continuing on with this. I'll probably be playing Borderlands tonight though, if anyone's interested in that. But yeah, see everyone later. That'll be the end of this stream. I suck at using my OBS keybinds. Everyone have a good day. I'll see you later.